All right, folks, hey, here we are in section 7.4. We are dealing with rational exponents. Again, in order to really understand this section, you have to start with the Algebra 1, the stuff that we did back before spring break when we focused on the rules of exponentiation from chapter 8 of Algebra 1. Understanding those rules and properties will make this a whole lot easier. And so if you're still struggling with that, I encourage you to practice that yet again. Obviously, reach out and ask questions as you have them. But focusing here on section 7.4, we're talking about rational exponents, which means exponents that are fractions or exponents that can be expressed as rational numbers. And so essentially what we're going to find out here is that we can write radicals as rational exponents. So the nth root of a can be written as a to the 1 over n power. All right, so this is a new rule, a new property of exponentiation. Add that to the list of other things that we know, like a to the negative 1 is equal to 1 over a, or a to the negative n is equal to 1 over a to the positive n. And so we're going to be using that here, this understanding that the nth root of a can be written as a to the 1 over nth power. Likewise, we can say a to the m over n is equal to the nth root of a to the m, or the nth root of a taken to the mth power, all right, just depending on what is more convenient. Or is it more convenient to take the root of the power or the power of the root? Again, when you're simplifying, you'll make that judgment call. They're equivalent statements. So here are just a few quick examples that I think may be beneficial to you as you are looking through these examples. Again, your textbook can be really, really valuable here. And so again, I want you to reference section 7.4 as needed. But here, this would be the fifth root is the denominator of our fractional exponent. The fifth root of x cubed is how we would write x to the 3/5 power. Again, the index is the denominator, the numerator is the power of our base. Here we have the square root of a cubed. Well, we don't need to put the 2 there as our index, so we can just write the square root of a cubed. In some cases, you will be asked to then simplify that radical as is possible. We're going to assume that our variables are positive here and call that a times the square root of a. Finally, y to the negative 3/8 is going to be the same as 1 over y to the positive 3/8. You'll want to address the negative exponent first pretty much always, although you'll have that opportunity to be flexible as needed. And in this case, we would write that as the 8th root of y cubed. In this specific unit, we're not concerned, or I'm sorry, in this specific lesson, I'm not concerned with you simplifying that radical expression from there. Again, if we needed to simplify that radical expression, you should be able to simplify that radical expression. We would multiply by the 8th root of y to the 5th over the 8th root of y to the 5th, so that we would make the 8th root of y to the 8th power, which is going to give us y, and that would give us the 8th root of y to the 5th over y as our simplified radical form. For the purposes of this specific lesson, we can stop right here and be okay. All right, we're writing it from rational exponent form to radical form, and in some cases not necessarily simplifying if it's going to take a lot of effort for us to get there. All right, obviously this, we can simplify that probably without much hassle. All right, what if you have a situation where you have a decimal as your power, or if you have, your decimal as your exponent, and if your power is a numerical power. And so here we have a numerical base with a numerical exponent. What we're going to do first is rewrite this as a rational exponent represented as a fraction. All right, writing negative 3.5 as negative 7/2 is going to help us understand that we are taking the square root. We are taking the square root of 4 to the 7th power. All right, to the negative 7th power. So let me stop right there. Let me fix that and write it in correct exponential form first. Take care of that negative first. It'll make your life a whole lot easier. So we have 1 over 4 to the 7/2, which means that we have 1 over the square root of 4 to the 7th power. All right? And, you know, we know already that the square root of 4 is 2. So, again, this isn't going to rock our boat too much, but when we take the square root of 4, we get 2, but then 2 to the 7th power, we may need to compute. 2 to the 5th is 32, 2 to the 6th is 64, so 2 to the 7th should be 128. And we're going to write our answer not in decimal form, but in fraction form. Alright, so that was just some quick examples of converting from rational exponent form to radical form. Obviously, if you have numbers involved, then you can straight evaluate that, alright? And you can write that in its simplified form as you ought to. The last little bit of examples, we are going to deal with some of these expressions that look very similar to the exercises I had you do for your Algebra 1 review when we were practicing those properties of exponents. And what we're doing here is the same exact thing, practicing those properties of exponents, but we have this new concept that we are going to apply to that old Algebra 1 understanding. So when we take a product to a power, we give the exponent to each of the factors. There are multiple ways you can do these. You can simplify the 16 and write that as 2 to the 4th power. You can write this in correct simplified exponential form first by putting it as 16 over y to the 8th and then applying the negative 3/4 power. I tend to like to work from the outside in, that way I don't have to keep flipping fractions, you know, if needed. But we're going to write 16 to the negative 3/4 times y to the, we're going to multiply, when you take a power to a power, you multiply the exponents. And so this will give us positive 24 over 4, or 6. And then this means that we have y to the 6th over 16 to the positive 3/4. Again, if we are simplifying this, we need to write the 4th root of 16 and then cube it, which is going to give us y to the 6th over 2 cubed, or y to the 6th over 8. Y to the 6th over 8. Sorry again for the handwriting. This is what we've got to work with, and so sorry I haven't been able to get out to Office Depot, you know, during a pandemic here. So this is what I've got. So again, we are taking step by step. You can watch each one of those steps. You can go back if you needed help to follow that. Again, the same thing is true over here. Although we don't have a negative exponent on the outside, so I know I'm not going to be flipping twice. We can give the exponent to both numerator and denominator, or we can simplify what's inside first, which is kind of what I'd recommend. We're going to simplify what's inside first by writing that in this format. Bring that negative exponent to the numerator and making it positive. And now we're going to take the product of powers to a power, which means we're going to give the power to each of the factors, and when we take a power to a power, we're going to multiply. So I have x to the 1/4 of 12 and y to the 3/4 of 12 to get our final form. All right? Again, if you want to see that in maybe one more step, I know I said it out loud, but if you are struggling with fractions, again, that elementary math is usually the issue that folks have in dealing with these situations. We get x to the 3rd, y to the 9th. Yep. X to the 3rd, y to the 9th. Alright, so that is section 7.4. I encourage you to get practicing on your 7.4 work.